Lesson 4.2 is about the unit circle, so we're going to start with a recap from 4.1. So to convert to degrees, all you do is you multiply by 180 at the top and pi at the bottom, because the goal is to cancel off the pi, so you want that on opposite levels. And then you're going to go 15 times 180, and you're going to divide that answer by 4 to get 675 degrees. Or 675 degrees as your answer. The next one, they just want to figure out what angles are coterminal with 30. Well, what you can do is you can convert these to degrees if you want to, or you can convert this guy to radians. So if you want, 30 degrees is actually going to be pi divided by 6. So if I add 2 pi to that, I get, so I would have to make sure that I get this guy would be pi over 6 plus, to get 6 at the bottom, you would have to have 12 pi over 6. So that would be then 13 pi over 6. Okay, so as you can see, that answer is not there. So I'm going to add another 2 pi, which means that I'm going to add 12 pi over 6 again to it. 13 plus 12, you're just adding the numbers in front of the pi's, you get then 25 pi over 6, and that matches that angle right there. Now, if you took pi over 6 and subtract 2 pi, you wouldn't get the negative 13 pi over 6 and then negative 5 pi over 6. So that's why I started with the positive, and if it didn't work, I would have gone and subtracted until I got the other answers. So D is your answer. Now, on a unit circle, the radius should always be 1. Now, in this shape here, we can actually use Pythagorean theorem to find our x and y coordinates around the circle. So let's say we have one of our values of x or y, we can plug it in to solve for the other one. So this becomes easy and helpful for the other examples here. Now 1 represents your radius. So the actual equation of a circle is x squared plus y squared equals r squared. So the radius squared. So in this example, they want you to find out what the radius or what the equation of the circle is. So you're going to have x squared plus y squared, that's how you make an equation, is equal to your radius squared. So all you have to do is simplify by putting 6 squared in your calculator and getting 36. So that is the equation of a circle with the radius 6. Example number 2, they just want you to find the missing coordinate. So we're just going to plug that in. It says we know it's on the unit circle. So what we're going to do is we're going to plug in the coordinate and then solve for the variable, or solve for what's missing. So we know that on the unit circle, x squared plus y squared equals 1. Well, our x value is negative 5 over 8. We're going to square that and subtract it from 1. So that will be then 25 over 8 squared is 64, and that's equal to, let me just move this over, plus y squared equals 1. And so y squared is equal to 1 subtract 25 over 64. So you're going to subtract 25 over 64 from 1. And that gives us that y squared equals 39 over 64. Now what we're going to do is square root this. So whenever you square root it, you can have positive or negative answers. So when we square root 39, it's not a nice number, so I want exact answer, so I'm going to leave it like that. And then over the square root of 64 is 8. Okay, so they don't tell us what quadrant it's in, so it could be in quadrant, the answer could be in quadrant 2 or 3. So in quadrant number 2, if x is negative, then y would be positive. So that's one answer. And for quadrant number 3, they would both be negative. Okay, so those are our possible solutions. Our next one, we have x is unknown, so we have to solve for it. So we're going to have x squared plus 5 over 13 squared is equal to r squared, which is 1 squared, 1. So we're using that unit circle equation. Now we have that x squared plus 25 over 13 squared is equal to 169 equals 1. We're going to subtract 25 over 169 to the other side. And you should get that x squared equals 144 over 169. Now we're going to square root both sides, leaving us with positive negative 12 over 13. Now, since this answer is in quadrant number 2, the x value has to be negative. So the only solution that's possible is negative 12 over 13 and the positive y coordinate of 5 over 13. So that's your final answer there. Now, example number 3, it says if a point at the intersection of the terminal arm and the unit circle, determine the exact coordinates of each of the following. We need the coordinates when it comes to the unit circle are always x, comma, y. X always represents your cos value and y represents your sine value. So what they're really asking us to do is get the coordinates of cos of 5 pi over 6 and sine of 5 pi over 6. So what I recommend you guys do is I'm going to show you how to use the unit circle. So creating the unit circle and then using the unit circle. So this is what the unit circle does. So I'll show you how I created that. So I've started by splitting my page into the Cartesian plane, where I have this is equal to 0 or 360 degrees. So remember, 0 is equal to 0 radians and 360 degrees is equal to 2 pi. So I started by labeling that. Now the coordinates on the side lengths, we can fill that out. Those are called quadrantal angles. So this angle right here on the unit circle would always be the same. It would be 1, 0. This angle at the top would be 0 and 1. This angle here would be negative 1 and 0 if the radius is 1. And this guy right here is 0 and negative 1. Now this is equal to 30 degrees. So if you remember, we did special triangles last year in 20-1. So what we want to do is figure out all these different values. And what I'm going to do is I'm going to find out that 5 pi over 6, if you look at this value right here, that kind of tells you what the reference angle is. The reference angle is pi over 6. And what you want to remember about pi over 6 is that pi over 6 is equal to 30 degrees. Okay, so that means this right here, pi over 6. So if it's 30 degrees, we're going to look from this triangle, this special triangle right here. So what we're really finding is that 5 pi over 6, guys, is in the second quadrant. So that means that cos is going to be negative in your second quadrant using the CAST rule, should be actually here, CAST. Okay, so since 5 pi over 6 is less than pi, we know that it's in the second quadrant, so I'm going to put negative 5 pi over 6, or negative just pi over 6. That'll make it easier. So I'm using the CAST rule to figure out what sine it is, and then the reference angle, which is 30 degrees. And this one's going to be sine positive because in the second quadrant, sine is positive, and that's going to be equal to sine 5 over 6, pi over 6. So it's going to be a positive answer for that. Now, looking at our special triangles, we know that pi over 6 is 30 degrees, so we want the cos of that. So cos is equal to your adjacent side over your hypotenuse. So we're going to write negative 3 over 2, negative square root of 3 over 2. Okay, so I use these two angles to get my answer, this guy here and that guy. And for sine of 30 degrees, you're going to look at 30 degrees and you're going to do opposite over hypotenuse, so that's going to be 1 over 2. Okay, so 1 over 2, and that is our answer there. Okay, so we're trying to find the cos value and then the sine value, and that would be the coordinates, the exact coordinates on the unit circle. So what I'll do is I'll label that over here. So I know that 5 pi over 6 is equal to negative root 3 over 2 and 1/2. Okay, let's look at our next example. So they want the coordinates of cos negative 4 pi over 3, and they want sine of negative 4 pi over 3. Now, what you want to figure out is how many pi's, where is this along the actual triangle? So what I'm going to do is draw this. I know that I'm going now clockwise. So if I were going in pi's, so this is kind of how it's divided. So each quadrant, so pi is being divided into 3 parts. 1, 2, 3, okay, without even this middle piece. So pi, normally a straight line, is being divided into 1, 2, 3, and then 4 parts. Okay, so this is going to be pi over 3. This is another pi over 3, and this is another pi over 3. Pi over 3 is equal to 60 degrees. Now, 3 of them will make 180 degrees, and another pi over 3 will make 4 pi over 3. And since we're going clockwise, that's why we have a negative sign. So we wanted to figure out where that was when it came to angles. Okay, so we know that we're in quadrant number 2, so that's important. Quadrant number 2. Okay, so that's going to help us with our answer. We know that we're going to have a negative cos value of pi over 3, and we're going to have a positive answer for sine pi over 3. Okay, so I can kind of ignore this number in front and just look at, when I'm looking at it, I'm just looking at these two values to figure out what my reference angle is. And pi over 3, guys, is equal to 60 degrees. So that's kind of helpful for us, because when we look at our special triangles, we know that we're looking at the 30, 60, 90 triangle. Okay, so when I redraw the triangle, that will help me figure out my answer, because negative cos of 60 degrees, which is pi over 3, is equal to negative, you're going to do from 60 degrees, your adjacent side over your hypotenuse. So that's going to be negative 1/2. And for sine of pi over 3, you're going to go opposite from 60 is root 3 over your hypotenuse, which is 2. And that's how we get our answer. Example number 4, we want to identify the measure of the central angle in the interval from 0 to 2 pi, such that pi theta is the given value. So what I like to do in this case is, I know that the first coordinate is cos theta and the second coordinate is sine theta. So what I'll do is I will actually go cos inverse of the absolute value of that, meaning the positive value of that. So that's kind of like a quick way of doing this, is I'm going to go sine inverse of root 2 over 2. And I get 45 degrees. And 45 degrees is pi over 4. So pi over 4, remember if you convert 45 degrees into radians, that would be like dividing by 180 and changing it to a fraction. So pi over 4. So we know that we're talking about, first we need to figure out what quadrant we're in. So that would help us as well. So when both cos and sine are negative, CAST, that means we're in the third quadrant. So we have an answer in our third quadrant with the reference angle being pi over 4. So we are going this way. In this case, we're going from 0 to 2 pi. We're not going in the negative direction. It wants us to go from 0 to 2 pi in that interval. So there's only one solution here. Okay, so what you can do, a quick way to find that angle is, if we already know the reference angle, we know that 180 degrees is equal to just pi. If you take pi and add pi over 4, that's going to be the rotation going up to that terminal arm. So that would be then, common denominators, 4 pi over 4 plus pi over 4 is equal to 5 pi over 4. And that's how I got my answer. And you can even check. If you put that into your calculator for sine 5 pi over 4, you should get the decimal form of negative square root of 2 over 2. So that would be a way of confirming your answer. Okay, so that's it for lesson 4.2. So what you want to do is kind of use degrees and then it might help to convert them to radians and work in that kind of the frame. So I kind of go back and forth in my head to make it a little bit easier using the special triangles.